We're tackling a challenge that's becoming increasingly critical across North America: internal corrosion in crude oil transmission pipelines. This issue isn't just a maintenance concern anymore, it's a major threat to long-term pipeline integrity, operational uptime, and environmental safety. PHMSA data continues to highlight a steady rise in internal corrosion-related failures, and what's troubling is that many of these failures occur despite operators following standard industry practices. Why? Because those conventional hazard assessment models are oversimplified. They don't reflect the real complexity of crude oil pipeline systems. These lines don't just carry oil, they carry risk in the form of water, sludge, sediments, sulfur, and sometimes oxygen, especially when crude is sourced from upstream tank farms via truck transport. That's where QIC offers a powerful advantage. This advanced tool combines mechanistic three-phase flow modeling with detailed corrosion algorithms. Using simulators like PipeSim and Olga, QIC accurately characterizes oil-water slippage, allowing operators to pinpoint where water will settle and create stagnant zones, those hidden corrosion traps that traditional models overlook. But QIC doesn't stop there. It also integrates data on episodic ingress of oxygen and biomass, which often enters the system during offloading at upstream terminals. These contaminants dramatically increase localized pitting risk, especially during intermittent or shut-in flow conditions. QIC accounts for this dynamic behavior to build a more accurate corrosion profile. One breakthrough strategy is the MEG injection approach. Rather than relying on conventional inhibitors that need high water velocity to form protective films, QIC recommends injecting monoethylene glycol. MEG mixes with the water to create a non-corrosive solution, especially critical during low or no-flow conditions, when stagnant water poses the highest risk. The system also identifies where increased mechanical pigging should be used to remove settled solids and sludge after contamination events. This combination of predictive modeling and operational response helps break the chain between contamination and corrosion damage. QIC provides a corrosion hazard profile that is dynamic, targeted, and tailored to actual pipeline conditions. It evaluates not only where corrosion may happen, but why it will happen and what to do about it. The approach also integrates inline inspection data to validate the mitigation strategy's effectiveness over time. That means pipeline operators gain actionable intelligence. They can adjust chemical treatment plans, pigging schedules, and even upstream storage procedures. And because the tool helps prevent the activation of pre-existing corrosion sites, it significantly reduces the risk of unexpected failures. The result? Lower long-term costs, fewer unscheduled repairs, greater regulatory confidence, and enhanced reliability across your entire crude oil transportation network. If you manage crude oil pipelines, especially those exposed to intermittent operation, upstream contamination, or trucked-in supply chains, it's time to elevate your corrosion strategy. QIC isn't just another tool, it's a smarter way forward. Thanks for joining us on the Trusted Pipeline Advisor podcast.